All right, here's lesson 5.4. Here's the second video, and we'll continue where the first video left off. Just a couple more of these problems that use the addition identities for sine and for tangent. So here's the question. Here's the sine of sine of negative 15 degrees. And the first thing you might want to remember about negatives in a sine is it's going to be the opposite of the sine of 15 degrees. So a good strategy would be, let's just do the sine of 15, get your answer, and at the end remember, oh, wait a minute, there's a negative sign at the end of this. So let's, when we're doing the sine of negative 15, let's ignore it. Let's just go with the sine of 15 degrees. And look at your chart with a 30, 45, and 60 in there. How do you get 15? A couple ways. You can go with 60 minus 45, or you can go with 45 minus 30. I chose here 60 minus 45. Okay, remember your identity? If not, look back at it. It goes sine of 60, cosine of 45, minus cosine of 60, sine of 45. And at this point, it's just a matter of looking things up in your table. Sine of 60, square root of 3 over 2, cosine of 45, root 2 over 2, cosine of 60 was a half, sine of 45, root 2 over 2. Same rules with square roots as before. I have square root of 6 minus square root of 2, whole thing over 4. And don't circle it yet. That's not quite your answer. Remember, we're doing the negative. How does that affect it for a sine? It makes it the opposite. So my answer is exactly the opposite. So I can stick a negative out in front, and that would be okay. Or if I distribute, then all of a sudden my root 2 becomes positive, and my root 6 becomes negative. And that would be a nice way to write it just like that. Root 2 minus root 6, all over 4. All right, next question. Let's do the sine of pi 12. Ooh, don't know if you like radians so well. If you don't, let's switch it to degrees. Remember your conversion factor, times 180 over pi. Look at that. The pi's are going to cancel out on you. How many times does 12 go into 180? How nice is that? 15. So this question really is the same thing as finding the sine of 15 degrees. And didn't we just do that in the past problem? We did. So no need to do it again. You could if you'd like. But that's going to be root 6 minus root 2, whole thing over 4. We had just done that problem. All right, let's try another tangent one. Tangent of pi 12. Well, we just converted that. We know that's a tangent of 15 degrees. How do you get 15? 60 minus 45? Well, this time let's go 45 minus 30. It makes the problem just slightly messier, but it will be okay. The 60 is a little more preferable because tangent of 60 is root 3. The tangent of 30 is root 3 over 3. You're going to get an extra fraction in there when we use the 30, but let's just do that so you can see what that looks like. Okay, we haven't used the tangent identity as much, so let's just kind of scroll back and remind ourselves what the tangent identity even is. So go back, it's on page 2 of your notes. And we've got the subtraction one this time, so we kind of scroll down here. So we have the tangent of, we have 45 minus 30. And so it's going to be the tangent of 45 minus the tangent of 30. So you've got a minus in the top, and a plus with a product on the bottom. Okay, I think you remember that. If not, scroll back. It's in your notes. So here we go. We've got the tangent of 45 minus 30. How did that go again? It went the tangent of 45 minus the tangent of 30 all over 1 plus the tangent of 45 tangent of 30. All right, let's look these up. We know there's going to be a little bit of algebra to do as well. Tangent of 45 is 1. Tangent of 30 is root 3 over 3. Here I've got 1 plus 1. Tangent of 45 is 1. And I've got this root 3 all over 3. Okay, couple things wrong with this fraction. First of all, there's square roots in it. You can't leave square roots on the bottom of a fraction. Second thing is, you have fractions within the fraction. Look at this. There's a fraction. It's over 3, and then it's the bigger fraction here. And so what do you do about that? Well, let's take care of the fraction first. And how would I do that? Well, since the fraction on the bottom is 3, let's multiply the top and bottom of my fraction by 3. And I'm going to distribute that. I'll take 3 times the first, 3 times the second. I'll take 3 times the first, 3 times the second. So on top, 3 times 1 gives us 3. And here for the second one, I multiply, the 3's cancel out, so I get minus root 3. Not so bad. On the bottom, the same thing. I distribute. 3 times 1 is 3. The 3's cancel out, and I get just this root 3. Okay, guys okay with this answer? Hope not. We've got a square root on the bottom. What do we do with that? We multiply by the conjugate. So on the bottom, I have 3 plus the square root of 3. So I will multiply by 3 minus the square root of 3. Because this sign was a plus, I chose the opposite. I chose the minus. I need to do the same thing to the top. And again, it's coincidental that the conjugate happens to be the top of the fraction. That doesn't always work out that way in algebra when we do it. But I was looking at the bottom. It was 3 plus root 3. And I chose to multiply by the conjugate. All right, on the bottom, let's FOIL this out. First gives me 9. The outside gives me minus 3 root 3. The inside gives me plus 3 root 3. Look, they're going to cancel out. That was the whole point. And last, root 3 times root 3 is 3 with a negative sign. On the top, first gives me 9. Outside gives me 3 root 3 with a negative. Inside gives me 3 root 3 with a negative. And last gives me just a 3. Root 3 times root 3 is 3. Okay, what cancels out? Right there. Those cancel out. You have a negative and a positive. And so I end up with, see if we got room, 9 minus 3. I've got a 6 on the bottom. Combine like terms on the top. 9 and 3 is 12. And I have minus 3 root 3. Minus 3 root 3 is minus 6 root 3. Reduce the whole fraction by 6, and it looks like 2 minus square root of 3. A lot of work for that answer, but kind of nice practice with your algebra. So a little bit of trig going on with your addition formula, or subtraction formula in this case, then a whole lot of algebra too. All right, a couple more of these. Can you go backwards when I give you a problem like this? Look at this, sine, cosine, plus cosine, sine. Wait a minute. That's my sine addition formula. That's the sine of 25 plus 65. Do inside the parentheses first. That's really the sine of 90 degrees. I know the sine of 90 degrees. That's 1. So I recognize this. This is the backwards version of my addition formula. They gave me the addition part, and I knew that was the sine of 25 plus 65. Okay. And we got these last two are the ones that are involved. I think I'm going to save that for the third video. So we are done with 2 with 1 more video to go.